Hi, and welcome back to the class on ratio and proportion. I hope you have gone through the class on ratio and proportion that we had done before that, and I believe that you've solved a good number of questions on those concepts. Today we move on, and another form of proportion is what we call as variation. Variation also is nothing but proportion, but a very interesting concept and very, very frequently asked in a lot of exams. So let's look at what do we mean by variation. So as you can see here, variation is basically when one quantity changes with respect to the other quantity, then the two quantities are said to vary with respect to each other or are said to be proportional to each other, or in general we call that there is a variation between them. Okay. Let's take one very simple example. We take the example of, let's say you have time, speed and distance. That's a concept that we'll cover in some time. So let's say if time is constant, that means you have to drive your bike, car, vehicle, run yourself, everything for 1 hour. This 1 hour is constant. Now if your speed is 30 kilometers per hour, let's make this 2 hours. If your speed is 30 kilometers per hour, your distance covered will be 60 kilometers. If your speed is 45 kilometers per hour, your distance covered will be 90 kilometers. If your speed is, let's say walking, your speed is 5 kilometers per hour, you'll cover a distance of 10 kilometers. So now this speed and distance, if you see, when we made distance speed 1.5 times, 30 and 45 is 1.5 times, the distance also became 1.5 times. Can you see that? Similarly, when I made speed 1/6, 5 is 1/6 of 30, the distance covered also has become 1/6. So whatever you do to speed, the same thing happens to distance. When speed is multiplied by 1.5, distance also gets multiplied by 1.5. When speed is multiplied with 1/6, that means basically divided by 6, distance also gets divided by 6. If you multiply the speed by 2, let's say instead of 30 you go at a speed of 60, distance also should get multiplied by 2, and instead of 60 you will cover a distance of 120. Right? If you make speed half and you go at a speed of 15, your distance will also become half and you'll cover a distance of 30. So you can see whatever is the variation in speed, same is the variation in distance. And this is a classic example that distance is directly proportional to speed. Okay. And this is the symbol that we use between them. Okay. This is the proportionality symbol. Okay. So broadly, if you see, there are two kinds of quantities. Both move in the same direction. What we are discussing here, distance and speed, you can see that they are moving in the same direction. So they are of the first type. Okay. And then in a bit, we'll come to the second type also. Now, one thing is very important here conceptually to understand, what do I keep on the left and what do I keep on the right? Why have I written distance is proportional to speed and not speed is proportional to distance? Okay. So the general convention, and understand this very carefully, the general convention is that y is proportional to x. That's how we write it, where y is the input variable. Input means you make a change in y, you make a change in x, you control x, and y is the output variable, which means you don't control y, but y changes because of change in x. Okay, so remember, x on the right hand side is the input, y on the left hand side is the output. Okay, so here if you look at distance and speed, what are you changing? You're changing the speed because of which distance is changing, right? Not vice versa. So what you are controlling is speed, hence speed is x, hence speed should be on the right hand side. Okay. So speed will be on the right hand side, and we'll say distance is proportional to speed, not speed is proportional to distance. This will be. Okay. And this symbol is the proportionality symbol. Of course, you can't solve any question with this symbol. So what we do for this symbol, is we remove this and we put a constant instead. So we say distance is equal to k into speed. Okay. So basically proportionality gets replaced by a constant. Okay. And this constant again has a very important role here. Let's take any value. Let's take 60 and 120. So my distance was 120 in kilometers is equal to k into speed was 60 kilometers per hour. Right? If you use this, you'll get k is equal to 120 kilometers upon 60 kilometers per hour. So your kilometer also will get cancelled. 60, 120 will give you 2. And you'll see k, you will get not only the unit of 2, but not only the value of 2, but the unit of hour. So k will come to 2 hours. And because k is 2 hours, this tells you that k is the unit of time. It is representing time. Okay. Hence, distance is equal to 2 hours, which is my constant, into speed. Okay. So you can find the constant, not only the value of the constant, but also the unit of the constant. So your final equation is distance is equal to 2 hours into speed, because we started by assuming that I am keeping this time taken as constant of. So this is your variation. This is a direct variation. Okay. I can similarly keep my speed constant. Okay. Let's do once again, and I can do my speed as constant, and I say that my speed is, let's say, 50 kilometers per hour. Okay. So my distance and time. If I run for 2 hours, I will cover 100 kilometers. If I run for 4 hours, I will cover 200 kilometers. If I run for 1 hour, I'll cover 50 kilometers. So when I double my time, you can see my time has doubled. My distance also has doubled. When I make my time half, this is half, my distance also has become half. So same relation here also. And what are you varying? Are you varying time or distance? You are varying the time taken to travel, and the distance automatically is changing. So by the same logic, here again, the relation should be distance is proportional to time, or distance is equal to kt, right? Input any one value. So 100 kilometers is equal to k into 2 hours, and you will get your constant is equal to 50 kilometers per hour. And the unit kilometer per hour will tell you that this is speed. So k is a constant speed of 50 kilometers. Okay. So distance is proportional to time when speed is constant. Similarly, distance is proportional to speed when time is constant. Okay. Combining these two is your equation which we use so much, that distance is equal to speed into time. Okay, that will come to later. Okay, but we can combine these two. From here, you will not get equal to, you will get proportional to speed into time, and you'll have to introduce a constant, distance equal to constant speed into time. And when you solve, you'll get k is equal to 1. Okay, and it will not have any unit also, so k can be removed. But I can combine different variations also, because you can see the left-hand side is same here. Both the left-hand side are same. So in fact, I can combine them, and the right-hand side and constant. So basically, if I do this slightly more in detail, distance is proportional to speed can be written as distance is equal to k1 into speed, because different proportionality, different variation, the constants will be different. And second distance is equal to k2 into time. If I combine them, it will be distance is proportional to k1, k2 speed time. But k1, k2 again is finally a constant, which is a product of two constants. So it can be replaced with one constant, and I can say distance is equal to k speed into time. Okay, so k is my constant here. Fine. Okay, so this was my direct variation. Second is my this part here, which says when both move in opposite direction, this is another variation. Both move in opposite direction. That means when one increases, the other one decreases. And when one decreases, the other one increases. In the same example, when does that happen? If I take distance is equal to constant. My distance is constant. So let's say I have to cover a distance of 100 kilometers. Okay. And now let's look at speed and time. If I go at a speed of 50 kilometers per hour, I will take 2 hours. If I double my speed to 100 kilometers per hour, time taken will be 1 hour. If I make my speed half, instead of 50, I make it 25, I will need 4 hours. Right? So now you can see here, when I have doubled my speed, my time taken has become half. Right? And when I have made my speed half, my time taken has become into 2. Okay. So here, this is moving in opposite direction. And this is a case of inverse variation. How do we write this? We write here. And now again, what is in your control? And so what are you controlling and what is the output? You are controlling the speed, right? Basis which the time is getting decided, because the moment you hit 100 kilometers, the total time taken becomes whatever time you've taken, right? So you are controlling the speed here. So we will say time is inversely proportional to speed. This is how you'll write 1 by s. Okay, time is proportional to 1 by s, and this is how you write a inverse proportion or a inverse variation. Okay, let's put some values to find out this. So I can say again, introduce the constant t is equal to k upon s, or st is equal to k. Okay, let's put the first value. Speed is 50 kilometer into time taken is 2 hours is equal to k. So obviously, speed is 50 kilometer per hour. Time is 2 hours. So k is equal to 100 and hour will get cancelled. It will be 100 kilometers. And because it is kilometers, you know that k is nothing but the total distance. So k is equal to 100 kilometers and that is the distance. So speed into time is equal to distance. This is what becomes your equation. So I think the best example or best understanding of variation is this. And in the same one, you can see that you have direct variation also and you have inverse variation also. Okay, so I hope we have understood this well. Shall we? Let's move forward and let's look at some more detail and then we'll start looking at questions. So when an increase or decrease in one quantity results in a proportionate increase or decrease in the other quantity, they are said to be in direct variation. That is what we discussed first, right? So your distance is in direct variation to time. Distance is in direct variation to speed. Okay, because if you increase time, and assuming of course here speed is constant, and this is speed, this is assuming time is constant. Okay, so if you increase in the first one, if you increase the time taken, distance will increase. If you decrease the time taken, distance will decrease. In the second case, when time is constant, if you increase the speed, distance will increase. When you decrease the speed, distance will decrease. So these are classic examples of direct variation. Okay. So here we basically say that distance is proportional to time. So this is the symbol that we have used, and x is directly proportional to y is how we call it. Okay. Also, this can be written as d is equal to kt and d is equal to ks, a speed, sp. Okay. Now this k, if k is equal to 1, then change in x is equal to change in y. Okay. So in our case, it was not 1, but let's assume that in the first case, let's say this speed is constant, speed is equal to 1. Let's say speed is equal to 1 kilometer per hour. So if your time taken is 1 hour, distance covered will be 1 hour. If your time taken is 2 hours, distance covered will be 2 hours. If your time taken is 3 hours, distance will be 3 hours. So if k is 1, obviously whatever change happens in x, the same change happens in y. If k is greater than 1, let's say speed is 5, or let's say speed is 10. Now, time taken is 1 hour, distance is 10. Okay, so you can see the distance increases much more. Distance increases 10 times as increase in speed. Okay, when your time taken is 2 hours, distance covered is 20. When your time is 3 hours, distance covered is 30. So when k is greater than 1, your distance will increase much more than time taken. Okay, and when k is less than 1, so let's say speed is half. Speed is only half kilometers per hour. Okay, when speed is half kilometers per hour, then let me just erase this part. So now when your speed is half kilometers per hour, when time taken is 1 hour, distance covered will be half. Time taken is 2 hours, distance covered will be 1. Time taken is 3 hours, distance covered will be 1.5. So you can see that now because k is less than 1, whatever change we are making to x, y is changing smaller. Okay, so here when this is 1, okay, this is half. When this is 2, this is 1. When this is 3, this is 1.5. So that's how. So it all depends on the constant. Okay, and that's how the change will happen. So these two are classic cases of direct variation. Okay, fine. Let's solve a couple of questions to understand this better. So the interest earned on FD is fixed deposit. When you put money in a bank, and you do it fixed, which means you say that, okay, I'm putting this money for 3 months or 6 months or 1 year, bank gives you a certain interest on that. Okay, so the interest earned on fixed deposit is directly proportional to the number of months for which it has been placed. So interest is proportional to months. You decide the number of months and the interest automatically gets decided. You don't control the interest, you control the number of months, right? So I can say that interest is equal to k into months, right? And FD placed for 42 months give an interest of rupees 1820. So this I can write here. 1820 is equal to k into 42. Okay. What is the interest earned on an FD placed for 72 months? Okay. So interest is equal to k into 72. This is what I have to find out. So these are my two equations. Equation 1 and equation 2. Okay. Now variation questions can always be done in two ways. Okay. And understand this very carefully. One, of course, is from the first equation, I can find out the value of the constant. Right? So if you look at the first equation, k is equal to 1820 upon 42 or 21 upon 910. And I don't think this can be, this is both are multiple of 7. So I can have 3 and I can have 130. Right? So I'll get 130 by 3. This I can put in the second equation and I'll get my interest is equal to 130 by 3 into 72. This is 24. So you get 2400 plus 30. So you will get 240, 720. You add them, you get 3120 as your answer. So first method is solving for the constant. You find the value of the constant and then you put it in the second equation and find whatever has been asked. But no one has asked you the value of the constant. So why should I waste my time on that? So the second method of solving it is that you just divide the two equations. I divide the two equations and my constant gets cancelled. Okay, so my constant gets cancelled and then I simplify it whatever I can. So I'll make it 21. This is 36. Okay, 21, 36. Both are multiples of 3. So 7 and 12. 7 and 18, 20. Can they get cancelled? So I have 1820s, 14 and 1400 and 420. Yes, I cancel with 7. So I get 2, then 42, that is 6, 0, right? I get 260. So my interest is equal to 260 into 12, which is 2600 plus 520, which is 3120. So you get the same answer. But in this case, I do not know the value of the constant. So the question is, do you need to know the value of the constant? If you need to know, then of course you should find that out. But if you do not need to know, then we can skip that and we can directly use this method. Okay, so this is my method 1 and this is my method. In method 1, I have found the value of the constant. Okay, and I got it as 130 by 3, which I have replaced in the second equation to find the value of the interest. In the second one, I have directly divided the two equations, cancelled my constant and found the value of the interest directly. Method 2 obviously will be faster and better. In case constant has not been asked, I'll always suggest that we do second question. Okay, fair enough. Let's look at next question. Okay, 60 liters of diesel is required to travel 600 kilometers using a 800 cc engine. If the amount of diesel required to cover a distance varies directly as the engine capacity of the engine. So diesel is proportional to capacity of the engine. Okay. So if you see first case, 60 liters is equal to constant into capacity was 800, and second time, I don't know how much, but capacity has become 1200. Okay, so you know first case it is a direct variation. Okay, when it is a direct variation, what I'll try to do is directly without getting into too much of this. Let's assume that the distance was same. Okay, if the distance was same, okay, then how much would you have required? Okay, so first case, let's assume the distance was same. So K into, so I want to know how much diesel was required. I just changed the engine capacity from 800 to 1200. So see, again, you can do this very intuitively also. This is a direct variation, right? It varies directly. So varies directly, as we saw earlier in all those speed time distance examples that we took. When the engine capacity has become 1.5, right? 800 has become 1200. That means it has become 1.5 times. My diesel consumption should also become 1.5 times. Right? So 60 should become 90. That is very, very simple. Or if I'm not getting that intuitively, let's just divide the two. We'll use the second method. We are not bothered about the constant. So I'll cancel the constant. This will be 2. This will be 3. This 2 will give me 30. So diesel will be 30 into 3. I will need 90 liters of diesel. Okay. But remember, this 90 liters of diesel I need, I'm only changing the engine capacity. The distance is still 600. Okay. The distance is still 600. Okay. But here, the distance actually to be traveled is 800. Okay. So 90 liters you need for 600. How many liters you need for 800? Now, this can actually be called now a proportion question. I'll say 90 is to 600 is equal to, I don't know what, X is to 800. It has to be in the same proportion because now the engine capacity has been taken care of. So this, if I look at 90 upon 600 is equal to X upon 800. So this is 3, this is 4, this is 30. So X is 30 into 4 or X is equal to 120. I am going to need 120 liters of diesel. Okay. So first we did variation, a direct variation through which we just changed the engine capacity and we found that to travel the same distance you need 90 liters. And then we changed the distance using proportion and then we found that X is equal to 800, X is equal to 120 liters. Okay. Invariably, if you see, basically you are saying that the mileage of the vehicle will remain same. Okay. Once you have taken care of the engine capacity. So when you need 90 liters to cover 600 kilometers, basically your mileage is 600 upon 90 kilometers per liter, which is a constant, right? So 600 upon 90 is a constant. So then given that 800 upon x should be the same constant. So using this, we calculated and we got x is equal to 120. Okay, simple question. Fine. Let's move on to the next question and let's see this. Now, this is a very frequently asked, asked in various types. We'll also ask you this question. We'll solve this question in two different formats, and a very good question which explains the concept of variation very well. The cost of diamond varies directly as the square of its weight. So cost is proportional to weight square. Okay. Once this diamond broke down into 4 pieces with weights in the ratio of 1:2:3:4. When the pieces are sold, the merchant got 70,000 rupees less. Find the original price of the diamond. Okay. So the diamond is 1K. Let's say the weight is 1K, 2K, 3K and 4K. Okay, let's say these were the weights, earlier weights, because I don't know, again, weight has been given in a ratio. The exact weight has not been given. So the weight is 1K, 2K, 3K, 4K. So the weight before breakage would have been 10K, 1 plus 2 plus 3 plus 4. Obviously, there will be no weight loss. Okay, so the initial cost, let's call it C1, is equal to, now I'll have to put a constant. I've already put K here. So let's say constant we normally put as K. So let's put this as not K, but we'll put it as X. Okay, so let's put this as X. So the the weight of the pieces is 1x, 2x, 3x, 4x. Before breakage, it would have been 10x. So original cost would have been K into 10x whole square. Okay, and after breakage, cost 2 will be K into 1x square, first piece, plus K into 2x square, second piece, plus K into 3x square, third piece, plus K into 4x square, fourth piece. This is simple. All 4 pieces will have different weights, different cost. I've just added all of them to get the cost of all the 4 pieces together. Okay, so now C1 is equal to K into 100x square, and C2 is equal to K into, now if you add 1, 2 square is 4, 3 square is 9 and 4 square is 16. So 16 plus 9, 25, 25 plus 4 is 29, 29 plus 1 is 30. You will get total of 30x square. Okay, and the merchant got rupees 70,000 less. So if I subtract them, C1 minus C2 is equal to, now this x square also can be combined with the constant. So you basically have, I can say that this is 100 kx square. These together, all of them go in the constant, and this is 30 kx square. So kx square can be taken together. So basically C1 minus C2 is equal to 70 kx square, which is equal to 70,000. The loss is 70,000. 70 gets cancelled. So kx square is equal to 1000. You don't have to bother separately about what is k and what is x square. This whole is the constant, which is equal to rupees 1000. Okay, so find the original price of the diamond. The original price of the diamond was this, right? So this we can take as C1 is equal to 100 kx square, right? And kx square, you know, is 1000. So 100 into 1000, which is equal to 1 lakh. So the original price of the diamond was rupees 1 lakh, right? Okay, simple question, but a very nice explanation of variation. Okay, so the original price was 1 lakh. After breakage, this piece was 1kx square. That means this was 1000. This was 4000. This was 9000. And this was 16,000. So together they added up to 30,000. Okay, whereas original piece was 100,000 or 1 lakh. Hence the difference was 70,000. This is the question. Okay, I hope you have understood. This explains the concept of variation very, very well. Okay, and this is a question that has been asked in CAD. And then recently this question was again asked in a slightly different format. Okay, let's look at that question also. Very interesting question. See, first part is same. The price of a precious stone is directly proportional to the square of its weight. Same concept. Okay, so cost is proportional to, or cost is equal to K into weight square. Same concept. But here it tells you that Sita has a precious stone weighing 18 units. So the initial weight is 18 units. Okay. If she breaks it into 4 pieces with each piece having distinct integer weight, then the difference between the highest and the lowest possible values of the total price of the 4 pieces will be 2,88,000. Then the price of the original stone is how much? There's a slight twist in this question, right? So basically 18 gets broken into 4 pieces. So 18 is equal to A plus B plus C plus D. Okay. So cost 1, C1 is equal to K into, let's say the weight is these are units. So you can just take directly 18. Okay. 18 square. Okay. How much is 18 square? 8 into 8, you have 64. 6 carry is 6, 8, 8, 16, 632, and then 3. Okay. So C1 is equal to 324K. And C2, after breakage, when you add all the pieces, it is A square K plus B square K plus C square K plus D square. Right? This is my cost. Okay. So basically now, one I have to find C2 minimum and one I have to find C2 maximum. Okay. And obviously they will depend on A square plus B square plus C square plus D square. So basically the challenge here is that I have to break A, B, C, D 2 ways. One way that A square plus B square plus C square plus D square is minimum possible, and in one case it is maximum possible. Okay. And this is classic CAT question where 2 or more concepts will be combined. Here you can see that this uses the concept of variation, but it also includes the concept of maxima, minima, you can so as to say. Now remember that if a number has to be broken into parts, okay, such that their squares add up to the minimum possible, basically you will have to break the numbers as close as possible. Okay, remember you'll have to break the numbers as close as possible. So if I break A, B, C, D into, let's say 3, 4, 5, 6, what is 3 plus 4 plus 5 plus 6? It is 18, right? Yes. So these are continuous numbers. Okay. Now if you see what is 3 square plus 4 square plus 5 square plus 6 square. This is 3 square is 9 plus 16 plus 25 plus 36. This is 86. Okay. Now this is the lowest possible score. Because square, remember, square increases disproportionately with the increase in the value. Okay, so I'm trying to keep each value as low as possible. See, the trick is I'm trying to keep each value as low as possible. But if you reduce any value significantly, let's say you say why take 3, why not take 1? So if I take 1 instead of 3, I'm reducing it by 2. So the last value instead of 6 will become 8, and 8 square 64 will be much, much higher than 36. So I try to keep the values as close and as much in the middle as possible if you want to minimize the sum of the squares. And by the same logic, if you want to maximize, I'm sure you would have understood, we'll try to keep the values as high as possible. So as high as possible, what I'll do, I'll keep all the values as low as possible except the last value. So 1 plus 2 plus 3 is 6, and then I get 12. So 12 is the maximum possible value. Okay. Now when you take their squares, 1 square plus 2 square plus 3 square plus 12 square, you'll get 1 plus 4 plus 9 plus 144. 144, 154, 158. This gives you 158, almost double of 86. So the maximum possible is 158, the minimum possible is 86. Okay, hope we are clear till here. Okay, so now C min, so let me write here. C min is equal to 86K and C max is 158K. I subtract the two, and this difference is given to me as 2,88,000 is equal to 158 minus 86. That is how much? 58, 68, 72 is 72K. And you can see that it's a perfect multiple, 4. So K is equal to 4,000. You get K is equal to 4,000. Okay. Now that we have got K is equal to 4,000, let's substitute that in the original equation. So original cost was here, C1. So C1 is equal to 324 into 4,000. Okay. So 324 into 4 will be 1296. 1296,000. Hence, answer will be choice B. Okay. So this is a small variation from the previous question, but you can see very interesting question where one more concept has been used, and this is, as I told you, very, very typical of CAT questions, that some concepts will be combined here. Okay. So I think we have done good number of questions. We have understood the concept